looking at these graphs, the topic we're looking at is finding the equation of a line from a given graph. When you're given a graph and you want to find the equation of a line, of that graph, for example, this first one, you firstly need to find the intercept on the y-axis. So that means for the first one, we have y equal to mx plus c. This is the general form, the general equation of a line. Okay, is that clear?
Okay.
What is the equation of a line?
Yeah.
Let me hear you. Y equal to mx plus c. Let me hear you
Y
say that.
equals to mx plus c.
Good, good.
Y
That's
equals to mx plus c.
good. Now, what is m? M is gradient. M is gradient. So I need to find my gradient while c is the y-intercept. Y-intercept is a c. Is that clear?
Yes.
So on this first graph, where did the blue line cut the y-axis? The y-axis is the line from top to bottom. Okay?
And x-axis is the one from left to right.
Yes, yes, very good. So this red line, where did the blue line cut the red line? On which number? That's on 4. Okay? So that means the
Yeah.
intercept is 4. Then we need to find the gradient. How can we get gradient? Gradient is when you pick two values on the line. When you pick two values on the line for your x and for your y, let's say y, okay, gradient m, you know, m equal to y2 minus y1 over x2 minus x1. So let us pick a value on this line. If I have this triangle, I will try to, rotate it left and align it with this particular distance. So if I, let's say, I align it such a way that it fits here, then I'm going to, can you see the triangle there?
Yeah.
So I'm going to trace it to y-axis. This is my y2, which is 8. And this is my y1, which is 5. Then you trace it to x-axis. This is my x2. Trace it again. This place is going to be my x1. Okay?
Okay.
So x1 is like 0.5. What is x2? That is 2. What is y1? Y1 is 5. Based on that triangle, okay?
Yeah.
Then what is y2? Y2 is 8. Now I can find my gradient. Gradient says this over this. Is that clear?
Yeah.
Good. So what is y2 now? That is 8 minus
8.
y1, which is 5, over x2. What's x2? 2 minus
X2 is
0.5. So this is
5.
going to be my gradient. Yeah. So my gradient now will be what? 3 over 1.5. Is that clear? And this
Yeah.
is like saying 30 over 15. So what's the gradient? 2. So the equation of that line will now be what? Y equal to mx plus c. What is m?
M is
What is m?
gradient.
What's value?
2.
2. Very good. What is c?
Yeah.
C
4.
equal to what? 4. Where did we get the 4 from? That's on the graph where the line
4.
meets this. Can you see it here? Can you see it here? Where
Yeah.
the blue line
With the
meet the
line
red line?
intercept, so
Good, good. So what's the equation of the line now? Y equals to 2x plus 4. Okay? Is that clear?
yeah.
Is that clear?
Yeah.
That's because M is what? 2. And C is what?
Yeah.
4.
2.
So let's do the
4.
second one. Yeah, let's do the second one while I will give you the third one as assignment, okay? Is that clear?
Okay.
So for the second one,
Yeah,
which
that's
is
fine.
B, yeah, for the second one, which is B, If you want to find the equation of the line mx plus c, I said firstly find the intercept. Where did the line meet the
Is it
y-axis?
is it
No,
is it
no.
diagonal? Two.
Yeah, two. Very good, very good. That means you're getting it. So that means our intercept is 2, okay?
Yeah.
Yeah, so let me try and put this properly. So if our intercept, oh, yeah, our intercept is 2 at this spot. Good. That means C is 2, C equal to 2. Then we need to find M. M is the same thing like y2 minus y1 over what? X2 minus x1. So we need a triangle again. Is that clear?
Yeah.
To determine the gradient. So the triangle is going to face that line. So let me put it across the line. So maybe I can even use that point of 2, then this point of you know this point of 2 and this point of the other. So you can see the triangle, right? The green triangle.
Yeah.
So if I trace it to this axis, this is my y2, 8 again, but my y1 is going to
So
be
why is
y1 is 2, right?
it's two? Yeah.
Good. Then my x2 is 2. Then my
All
x1 will
right.
be 0. Okay?
Okay.
Good. So to find my gradient, I will just say for the second one, what's my y2? That's 8 minus 2 over 2 minus 0. Okay?
Okay.
And this is is going to be what? 6 over 2, which is 3. So what will be the equation? M is 3 and gradient
Yeah.
is 2. Do you understand this now?
Yeah.
Good.
Can we do the third one? Oh,
Yeah, I said you would do that one as assignment against Saturday. Okay, is that clear? But
okay.
what you are seeing on the third one
Yeah.
is that it is the line is not facing. Uh, you know, it's like a decreasing value, decrease negative graph. Okay,
Yeah.
so the question says if log 10 to base 8 equal to x, then evaluate log 5 to base 8 in terms of x. So we're starting from the log 10 to base 8, okay? Is that clear?
Okay.
So we have
Yeah.
log 10 base 8 equal x. But we can split log 10. We can split 10 into 2 times 5, right? Because we have a 5 here, okay?
Yeah.
So this would be
Yeah.
log 5 times 2, giving us 10, okay? Still base 8
Yes.
equal to this x. Remember, under laws of or theory of logarithms, whenever we see multiplication, it means when we separate them, it means addition. Okay, so this is going to be
Yes.
log 5 base 8 plus log 2 base 8. So log 5 base 8 plus log 2 base 8 equal to x. Now, the question says we should find log 5 base 8, yes or no?
Yes.
And this is what? What
Log
is
five
this?
basic.
Very good. And that is what we are finding, right?
Yes.
So we'll make that one the subject of the formula. So we leave it on the left hand side, log 5 base 8, equal to x minus log 2 base 8. Okay? Is that clear?
Yes.
We just catapult the whole of this out and it becomes negative, okay?
Yes.
Then, now that we've done that, this could be our answer because this is what we are looking for. So this equal to this, but we have to simplify. We have to do what?
Simplify.
So we can conclude and say log 5 base 8 that we're looking for equal to x minus log 2 base 2 raised power 3. Where did I get 2 raised power 3 from?
Hmm?
Yes, where did I get this 2 raised power 3 from? Where did
Eight.
I get 2 raised power 3 from?
I saw you got from it.
From 8, right?
Yes.
Good. So, according to theory of logarithm, this power can come to the back of this log, but it will be reciprocal, okay?
Yes.
So, we can say log 5 base 8 equal to x minus 1 over 3 log 2 base 2. This power is the one that comes to the back and become 1 over. If it is this one that has the power, it will come to the back without being 1 over, okay? But because it's at the base, so that's why then you remember that
Hmm.
log of the same
I'm
base must
sir.
be 1. Okay, so you remember that log of the same base must be 1, right?
Yes, sir.
Good. So log 2 base 2 should be 1. Then what we're looking for, log 5 base 8 will be equal to x minus 1 over 3 times 1, which is x minus 1 over 3. So we can leave our answer like this, or we combine the fraction. I mean, the number and the fraction, okay? Which is going to be the LCM is 3. 1 in 3 is 3. 3
Yes,
times that's
sir.
3x. Do you remember that log of the same base should be 1?
Yes.
Okay, that's why this one will become 1, okay?
Yes.
And once it become 1, it doesn't affect this again,
Okay.
so you have it here. Is that clear? Then this becomes the
Yes,
answer.
sir.
So the answer is here, but we can still combine it by saying this is over 1. You find the LCM 3, then that will be 1 here, 3. 3 times x is 3x, 3 here, 1. 1 times 1 is 1, so minus 1. So this will be the final answer. Is this clear now?
Sir.
Okay, put it down. This question, the first step to take to solve this one is to make all of them have the same base. But as they are, do they all have the same base?
No.
Do they all have the same base?
No.
No. The base of the first one is root 2. The base of the second one is half. The base of the third one is 4. So we can see that all of those numbers can be regarded as 2. How do we change them to 2? That's what we want to look at. Log 4, base 2 raised by half, because 2 raised by half is the same as square root of 2, okay?
Yes, sir.
Then plus log 16, base 2 raised by negative 1. 2 raised by negative 1 stands the same as 1 over 2. And the third one, minus log 32, base 2 raised by 2. So all of them having base 2 now, but there are still powers there. So the powers can go to the back of each one and become the reciprocal, okay?
Yes, sir.
Now, we have The first one, this half is coming here, but 1 divided by half. 1 divided by half is 2. Like 1 divided by half. This will be 1 times 2 over 1, which is 2. So instead of writing half, it is 2 that will be at the back of the logarithm. So that will be 2 log 4 um, base 2. Then the second one will be this negative 1 is coming, but 1 over 1 is still 1. So it's only negative 1 that will be here, then log 16. Okay?
Yes, sir.
Log 16, then base 2. Then the third one, the 2 is coming here, but it's going to be 1 over 2. So minus 1 over 2 log 32 base 2. Now this minus and plus, minus will replace. Okay?
Yes, sir.
So we have log, say, and one other thing is that this number here can become the power here. Any number here can, come and become, but we don't even need them to go there right now. So it rather we will need to make all of the log to become 2 by raising them to base. I mean by raising 2 to a certain power to give us all of these numbers at the top. So that we can have log of the same base which will give us 1. So here we have 2 log 4 is 2 square base 2. Then minus, there is no need of 1 again. Log 16 is 2 raised power 4 base 2. Then minus half. Log 32 is 2 raised power 5, then base 2. So all of those powers will transport themselves to the back, okay, to multiply whatever number
Yes, sir.
is at the back. So this is now going to become this 2 times the 2 here, that will be 4. So this will become 4 log 2 base 2, then minus this 4 is coming here, minus the other one, which is also 4 log 2 base 2. Then this 5 is coming here to multiply half. 5 times half is 5 over 2. So that is minus 5 over 2 log 2 base 2. Now, it is 2 times 2 that give us 4 here. That's why we have this 4. Okay, we know that log of the same base should be 1. So all of them become 1. So what we have here now is 4 minus 5 over 2. So 4 minus 4 gives us 0. Then our final answer will be minus 2 and half, which is minus 5 over 2. Is that clear?
Yes, sir.
Okay, so I'll give you some time to put this down
Yeah, I'm done.
forward. Okay, you've written it as I was doing it, right?
No, I finished it before.
Okay. So, and did you follow the same method?
Not exactly, but then I now went to
Um,
go and copy.
okay, but try to explain this to me now so that I can be sure that you know what you
Okay.
yeah. Okay.
Mm.
It's not just about you having it in your note, but knowing how to do it if you're alone with the question in test, in exam, in whatever. That's the essence of me saying don't write anything whenever I'm solving it. I know we must have looked at one or two things like this before, right?
Yeah.
uh But since it's part of your topic as you just resume school, then we need to go over them. We don't just need to be rushing and be going. So try to explain this to me. Or do you want me to explain again?
No.
Okay, explain again.
Those
Yes, I'm waiting. Can you hear me? Hmm?
mm,
Can you hear me?
yeah, I can hear you, sir.
So I want you to explain it, okay?
Okay.
Or if you need me to explain it again, you let me know so I can just explain. Hmm?
Okay. Um, please explain that last part that you did.
The last
Not the
part.
the 5/2.
Wait, let me hold on. Do you mean this place?
Yes.
Okay. This place means this is log of the same base. This is 1. So 1 times 4 gives me 4. And this is also log of the same base, which is 1. 1 times 4 give me another 4. And this is also log of the same base, which is 1. 1 times 5 over 2 is 5 over 2. So 4 minus 4 is
How
gone.
do you turn it to 5/2? Was 1/2 before?
Okay, how it became 5 over 2, right? That means it's
Yes.
from this place. So this step, you have 2 uh, log 2 square base 2 from this place. Then we have negative, that's minus log 2 raised to power 4, which is from this 16, then base 2. Then we have half log 2 raised to power 5. Remember the 5 is at the top, right?
Yes.
So this 5 will come to multiply the half that is here. 5 times half is 5 over 2. That's 5 times 1, then over 2. Okay.
Okay, sir.
That's where 5 over 2 came from. And it's the 5 over 2 that gave us 2.5 here, but there's negative there. Is that clear?
Yes, sir.
Then let's say that let's just mention it a little bit from the beginning. We have log of um, we have log 4 base square root 2. Okay.
Yes, sir.
So and we have the other one log 16 base half. Is that clear? And the third one
Yes,
log
sir.
32 base 4. So all of the bases are not the same, but since we see plus and minus, we might want to combine them. That's why I said let us try to turn them to the same base, and 2 could be the same base. But I did not even have any reason to combine them um, after decoding that, oh, I can even simplify each one individually. Is that clear?
Yes, sir.
Okay, since I didn't combine them, you know, that will now, I don't have any reason to say I'm following the law of logarithm that say if I see plus, I should times them, and if I see minus, I should divide. But we're still going to meet questions with that. So since each one could be solved down to 4, and this one could be solved down to 4, while the third one could be solved down to 5 over 2, then definitely we just carry out this. So root 2 at the base gave us, it was the one that gave us 2 uh, raised per half. Then our base half that is here is the one that gave us 2 raised per minus 1, because when you have 1 over something, like 1 over a is the same as a raised per minus 1. Is that clear?
Yes, sir.
Good. Then 4 here is 2 squared. So this 2 will come to the back, but it will become 1 over. That's why it's 1 over 2 here. And this negative 1 will come to the back. It will still be 1 over, but 1 over 1 is 1. While this half will come to the back, but it's no more half because it's 1 over half, which is 2. Is that clear?
Yes, sir.
Good. So with this, we're able to say, okay, since this is 4 and this is 16 and this is 32, then they are all multiples of 2, then we can get 2 out of them. Then this is 2 square, this is 2 raised power 4, and this is 2 raised power 5. Then the powers can go to the back of each log, multiply any number that is there. So 2 multiply this, give me 4. 4 multiply not 1 that is here, give me 4 again. While 5 multiply the half here, give me this. Then this one led to 1, 1, and 1. Then we have only the numbers 4 minus 4, which is 0, and minus 5 or 2. So is this clear to you now?
Yes, sir.
Okay, just hold on a bit. We're going to look at another. This next question says if log 64 base x raised power half equal 3, find x. This one is it's in line with the law of logarithm that says log a base b equals c can be rewritten as a equal to b raised power c. So in this particular question, what's our a? A is 64, okay?
Yes, sir.
A is 64. What's our b? B is x raised power half. And what's our c? C is 3,
Yes.
okay? So that means a
Okay.
will be equal to b raised power c. So it means 64 will be equal to the x raised power half also raised power 3. Is that clear?
Yes, sir.
And in the indices, that's why I say logarithm and indices at the top there. Under indices, this what we have at the bottom is no more logarithm, but indices, this particular side, okay?
Okay, sir.
So whenever you have something like this and a power and another power outside, you multiply the power. This is a raised power b times c, which is a raised power bc, okay?
Yes, sir.
So what do you think I should do to the power there? 64 equals to x raised power half times 3. Half times 3 should give me what? That's 3 over 2, okay?
Yes, sir.
X raised power 3 over 2. Now, to get rid of 3 over 2 on x, I can do something. The first thing to do is to find the square root of, both sides. If I want to find the square root, or rather, the meaning, the implication of this 3 over 2 is what I want to explain. When you have a number raised to a number, then to another, like b over c, this power, okay?
Yes, sir.
It means the seat root of the number then raised to power b. For example, a raised to power half is going to be this c is in the root, which is the square root of a, then raised to power 1. Or a raised to power 1 over 3. Instead of square root, because it's not 2 again, it is 3, okay?
Yes,
So
sir.
that would be cube root of a, still raised to power 1 that is at the top. But if I have two numbers that are not 1, okay, like not 1 over 3, maybe I have a raised to power 2 over 3. What do you think that would be? That would still be cube root of a, but not raised to power 1 this time, but raised to power 2, okay?
Yes, sir.
What if I now have a raised to power 3 over 2? Will it still be cube root or square root? This will be square root because 2 is the one at the bottom of a, then raised power 3. So that is what we're going to do to x here, okay?
Okay, sir.
So this will be 64 equal to square root x raised power 3. So to remove the square root, we'll find this, we can square both sides. Let me put it that way, okay?
Yes, sir.
We can square both sides. And to remove the power 3, we can cube root both sides. So let me firstly remove the power 3. So to remove the power 3, I'll find the cube root of this and the cube root of, everything here. So that the cube root will cancel the power 3, but the cube root of 64 is going to be 4. Is that clear?
Yes, sir.
So if the cube root of 64 is 4, then I have 4 equal to square root of x. Okay? Because the power has been
Yes,
removed,
sir.
power of 3. Then the next thing is to square both sides in order to remove the square root. So I'll square this, then I'll square this. So this will cancel the square root. And I have 4 squared, which is 16, equals to x. So that means x equal to 16. And we can verify our answer if x is 16. Let us try to solve this and see if it's going to give us 3, because they said it must be equal to 3. Let's put x to be 16. Please watch this. Let's
Yes,
say
sir.
the question is simplify, or not simplify this time around, evaluate, because we can find the value. The value is 3 at the top. Is that clear?
Yes, sir.
And it's 3, but we want to work it out and see if it's going to give us that 3. So evaluate log 64 base 16 raised per half. It was 16 we got for x, right?
Yes, sir.
That's why we're substituting it to see if it's going to give us. Remember what we said, that log of the same base will be 1. That's what we target here. So this is going to give me, let me turn them to 2. So log of 2 raised power 6, which is 64, and 2 raised power 4, also raised power the half that is there. So this is now going to be log of 2 raised power 6, then the 4 times half. 4 times half on the power here, okay? 4
Yes, sir.
times half is 4 over 2, which is 2. So the power is going to be 2 at the bottom. Then both the power of the log and the power of the base are coming to the back. So this is going to be 6 over 2 log 2 base 2. The 2 at the bottom will be at the bottom. The 6 at the top will be at the top, right?
Yes, sir.
And you know that log of the same base is 1, so this is 1. The answer is 6 over 2, which is 3, times 1, which is 3. So that means our 16 is correct because we're able to calculate, and it gave us 3. Is that clear?
Yes, sir.
And so I'll give you some time to put down not only this solution, okay? You put
Okay,
down
sir.
this solution, then you also put down this explanation too. And when you are through, I'll move it to the bottom so that you can put down the verification, here that we try to verify it, okay? The check.
Okay, sir.
Okay. So once you're through with that, we round up the class for today.